Hello friends, welcome back. In the previous tutorial, we have learned how do we create a vector data structure, or I can say structure, and we have seen how do we create different vectors and display them on the screen. And we have also seen how the code works behind the scene. I hope you guys have understood. One thing you need to remember always is whenever you create a new vector, you will get back another vector. One by one the values will be copied and that vector will be removed after the operation. Now let's proceed and get some more information in this. Now I'm going to delete these things. We know now how vectors work. I can say vector 2D. Maybe I can say position is equal to new vector 2D, and I can use out of 3 any one I can use. I'm going to use the parameterized constructor to create the position. Maybe I say 100.0f, 100.0f, and we know that it creates a position vector with the x value 100 and the y value 100. If I want to make modification to the members of position, I can say x is equal to 300.0f. Now you should remember that your position vector has got changed, right? Now x is 300, y is 100, guys. It has changed. You can see that one if you want. Debug.log, I can say string.format, then I can say here position is equal to position x is equal to 0 and y is equal to 1, double quotation comma. You can say position.x will give you x, position.y will give you y, bracket close, semicolon. And if I comment this line, of course we should see position.x, position.y should be 100, 100. We know that we will get 100, 100. There is no problem in that. If I run the code, you can see that we got position.x is 100, y is 100. That means if I come over here, now you should think like our position vector is this much, and it has created, or you can say the object position is over here. It is at 100, 100. You can think like that. Now if you make modification at any time to the members of position x and y, let us take I modified x, I copy and paste it down. This time you should see position.x is 300, y will be still 100 because that we have not modified. We know that very clearly. If we run the code, you can see that position.x is 300, y is 100. Now you should think that you have modified the vector, guys. Now where the vector is pointing now? The vector is pointing from here to here. Now x is 300, y is 100, guys, over here. So now your game object is over here. If you changed both of them, position.y, if you assign y is equal to maybe 300 only, 300.0f. Previously it is 100, 100. You changed them to 300, 300. I think you got an idea that what output we get, right? Because we get x 100, x 300, y 300, then the vector will definitely get changed. Your position vector has got changed, guys, once you make a modification. Let us save and run and check. We should get the value 300 and 300. At any time you modify, you should think that behind the scene your vector is also changing. X is 300, y is 300. That means now the same vector is representing at 300, 300, my friends. So it is representing, or the vector is now, it looks like this. So previously position vector is this one, next the position vector changed to this, next the position vector changed to this. Currently you have a position vector which is having the x value 300 and the y value 300. I hope you guys are understanding how the vectors work. Now let us take, instead of assigning like this, of course I can modify. If I get a vector, I can modify its x and y members. We can also use a facility. We can create one function which can allow us to assign the x and y values to that vector. I create one function here which I can access anyway, public void set function, and it takes two values, float x and float y. And what is its responsibility? Its responsibility is set this dot x equal to x and this dot y equal to y. Very simple, guys. We know that one extra parameter we will be having, that is this variable, which will be always pointing to our current object. We are changing the current objects x and y, whatever we give. Let us save and check out how do we perform that operation. Now instead of this, I can say position dot set. You can see that we have a method set available and it is asking for us from us x and y. I can say here maybe 300.0f, 300.0f, right? Now you can see that when you create this position vector, it will be having the status something like this. The position vector is like this. Now after that, what happens when you say position dot set 300 300, your position vector becomes 300 300. That means it is start pointing this memory location, or not memory location, the position, you can say, on the plane. So your vector looks something like this, guys. This is your current position vector. And you can see that whenever you make modification to x and y members, the length of the vector and the angle of the vector is changing, that you need to observe. Now we have understood how do we create the position vector and set the vectors x and y members. If you want, you can you can add properties also. You can add x property, y property to get the x and y members. That's okay. Are you guys understanding? That you can try yourself, because that's not a difficult task. You know already how to do that. Now let us proceed and get some more information, my friends, about vectors. Now we have understood how do we create a vector, how do we modify the vector, how do we set the vector values at a time, x and y. Individually, if you want to set, you can just set the x, just set the y. If you want to set both of them, you can just call this set function. I hope you guys have understood. Let's get proceed. Now what we are going to learn now in this tutorial is we are going to understand how do we calculate the magnitude of the vector. Now we know the x and y. Let us take, we have a vector from here to x is 300 and y is 400. This is our vector. We created this vector, guys, and it has the x value 300 and y value 400, and that is a position vector. You can see that we have attached it to the origin. From the origin, this is a position vector, always dependent on the origin. We draw the position vector with respect to the origin. You can see that one. This is our position vector, let us take. And I want to find out what is the magnitude, the actual distance, you can say, from this 0, 0 to 300, 400, what is the actual distance? You already know how to find out that one, right, guys? You need to find out the x distance. You need to find out the y distance. Then you can use the Pythagoras theorem to find out the magnitude. You can say this one is the magnitude, guys. How do we do that? We already know how to we find out. Let us try that one over here. What I need to do is I need to create a vector 2D. Vector 2D. Again I say position vector is equal to new vector 2D with the value 300.0f is a x, 400.0f is a y. Now of course, if I need to find out the distance, I need to find out the x distance first. Float x distance is equal to position dot x minus 0, that is the origin, right? Origin dot x. I am not taking the origin as a vector, so I am just mentioning that the origin we know already, right? This is the x2, you can think. This one is a x1, the origin is x1, so x2 minus x1 I have to calculate. x2 is our position dot x and x1 is 0. Then I can say float y distance is equal to position dot y minus 0. That gives the y distance, that is y2 minus y1. And we know that in our diagram y2 is our position dot y and y1 is the origin y value, that is 0 there. That is what I am doing here, you can see that. Then I can find out the distance or the magnitude, I say. Magnitude is equal to, we can use math f dot square root of x distance I can put in a bracket x distance multiplied by x distance bracket close plus y distance multiplied by y distance. This will give us the magnitude of the vector, and we can see that we can say debug.log and display the magnitude on the screen, right? Let us save this one and run and check what we get, and then we understand. It is not a difficult one. If I run the code, you can see that we got 500. We have already calculated this before also. I hope you remember. That's the reason I am taking the same example, so it will be easy for you guys to understand. And one thing you need to note here, that you have 300 minus 0, you will get 300 only. 400 minus 0, you will get 400 only. So we actually need not to do this operation, guys. To find out the magnitude of the position vector, we can make it much more simpler. Instead of this, I can very simple code I can write here is float magnitude is equal to mathf dot square root of position dot x into position dot x. We know that one. The position dot x is, you can think like a x distance, of course, that is 300 into 300. The same thing we are doing. Plus, I can say position dot y multiplied by position dot y. Because we know that whenever I take this one, if I need to find out the x distance, I will get 300 only. If I calculate the y distance, of course I will get 400 only. So why don't I use the position dot x and y? That is better, right? I need not write 2 more lines finding the x distance and y distance. Now let us run and check. Of course we will get 500 again. You should see that if we are correct, right? We got 500. So let's proceed, and we know that now if I create one more vector, again I have to calculate one more magnitude and all. I make it much better, simpler. What we can do is we can create one method or a property. We say float, and I'm going to create a property here. Why I'm creating property, I will tell you. The magnitude is the property, and it is going to be only the getter. You cannot set the magnitude of the vector. If you are setting the magnitude of the vector, then you need to modify the x, y, lot of things you need to change. So better we just make it getter, so that nobody should modify the getter magnitude. Only they can get the magnitude. So what it does, it returns this dot x multiplied by this dot x. That is going to be x plus this dot y multiplied by this dot y. You can think like this is x square plus y square. We are using the Pythagoras theorem, and we give that one to mathf dot square root sqrt, square root of mathf square root of x square plus y square. That gives me the magnitude. Let us save and check it out, and then we proceed. I'm going to remove this because we will be not working like this further classes or tutorials. So now we have a position vector already created, and which has the x 300, y 400. We know already x and y, that is going to be x distance and y distance. So I can say here debug.log position.magnitude. You can see that I even need not to write anything, just I am writing position. I want to know what is its magnitude. Now our magnitude property is going to take the current object's x, multiplies it twice, takes the current object y, multiplies twice, then adds them, gives it to the square root, and that will give us the magnitude back. Now let us save and check it out whether we are getting the 500 or not, and then we understand, oh, we have a problem. Mathf does not exist in the current context. You can see that it is telling that there is no mathf. Can you tell me what is the reason behind that, guys? Can you tell me what is the reason behind mathf is not visible, it is telling? The reason is mathf, right click, go to declaration. We minimize this one and tell you what is the problem. You can see that mathf structure is present in the Unity engine namespace. So I hope you guys are understanding what I have to do. I have to write here using Unity engine, which gives me mathf structure. Now we come back, we will not be having any error message. Mathf does not exist will go away. It is in the current context, right? Now if I run the code, you can see that we have 500, guys. Now let us check it out, some other example if you want. Let me remove these things so that you get either other idea. This time maybe the vector, position vector is representing 400 and 300. That is the same thing, but at least you get idea, right? Now this time you have x, this is not 400, this is 500. Let us take 500 only. 500 in x, 300 in y. Now if you want to find out the magnitude of this vector, guys, of course you will be finding the x distance, but x distance will be 500 only, because 500 minus 0 is 500 only. And y distance will be 300. 300 minus 0 is 300. That's a y distance only. So we need not to worry about subtracting. We can directly use these numbers, right? This vectors, this position vectors, x component and y component I can use to find out its magnitude. That's simple. Or you can think like this. From here to here, how much far away this object is present in x distance? 500, right? That is going to be our x. And how much far the object is in a y distance? That is 300. That is going to be y. And we know that if I have to find this one, you can consider x, and this one is a y. So you can use to find out the magnitude is equal to Pythagoras theorem, x square plus y square. Let us come back and check out what we get for this one. 500, 300. Now this one is 500, this one is 300. I just save it. If I run the code, we should get some magnitude, and let us check it out what we get first, and then we try to understand if we want. And you can see that it is telling 583 is the magnitude. You can try, you can you can calculate yourself, guys. You know already how it works. If you want, you can create a method also. As I told, you can create a public method which returns a float. You can say the method name as get magnitude, and of course it won't take any parameters. It just returns you back, return this math f dot square root of this dot x multiplied by this dot x bracket close plus this dot y multiplied by this dot y bracket close semicolon. I just save it. You can see that I can write either a property getter, or I can create a get magnitude method if I want. We know that, right? And of course I can use that one instead of magnitude, right? I can copy this one. I just show you how do we do that. If I say position and I say dot get magnitude, function is available, and here I write two brackets because it is not a property, it's a method, and I just save it. And if I run the code, both values should be same, and let us come back and run and check it out. You can see that we got the same answers. But I am not creating this method. I am not interested to use this get magnitude function when I have a property. So I am removing this one. I hope you guys are understanding clearly step by step. I put this set function above so that we keep functions and constructors separate. Now whenever I want, I can modify the vector and check it out, its magnitude and whatever. Like position dot, let's take set. If you want to set the position now somewhere else, maybe you are changing the position to 400.0f, 300.0f, and if you want to find out again the magnitude, you can find out. And of course we don't have a get magnitude method. I'm removing that. And we know that whenever we change the x and y values, its magnitude is going to change definitely. But this time magnitude should be 500. We know that. Let us come back. We are not having any errors. And if I run the code, you can see that we have 500 as the magnitude. That is how you find out the magnitude, guys. It's very simple. If you want, you can create another vector and give some other x and y values and check it out. That's simple. Now if you want to find out the angle also, you can find out the angle of the vector. I am not interested to set the angle. So we are going to create another property known as angle, which is of a getter type. We are not allowing the setter. We are not allowing anybody to set the angle, because if we set the angle, we need to change its x, y, magnitude, right? Those are all we are not interested. We want to make it much simpler. Now what angle? How do you find out the angle? It just returns back to us, return we need to use a mathf.atan2 function. You have atan also, atan function, which takes a float value. Actually, you have to pass to that function y divided by x. You need to pass. Instead of that, you can use atan2. That's much simpler. There you need to pass the y value, this dot y and this dot x. You pass to it. It is the y distance and x distance, you can say, are just y and x. That is the same thing. And you can add 360 degree to it and mod it to 360 degree. That will give you the value between in degrees, angle in degrees you will get. And you can save and check it out if you want. Let us take an example of a vector. Let me remove these things and get some examples of vectors. Let us take our vector is now looking at here. This is our position vector, or maybe our player or enemy is present at 0, 300. 0 is x value and the y value is 300. You can say that the enemy or a game object is present at 0, 300. That is x, that is y. And we can find out the magnitude. Of course, the magnitude should come 300 because that is the length of the vector, and the angle should be 90 degree. You can see that, and we can say that it is looking up. That's how we calculate. And now we know the formulas and we have kept that. Let us check it out. Let's create our position vector now. X is equal to 0.0f and y is equal to 300.0f. We are not changing the position. We just want to know what is the magnitude. Write one more line to say debug.log. What is the position dot angle? That's it. As it is a property, I'm just writing the name of that one. I can just save and come back to Unity. If I run the code, you should see magnitude 300 and it is 1.570796. That is actually, we are getting in radians again. I think you know what mistake I have here. I have to multiply this return value with mathf.radians to degrees. I have to multiply the return value because atan2 function returns in radians, and I convert that to degrees by multiplying radians to degree. Then I add 360 and mod by 360. Now let us come back again and run the code and let's check it out. We have the 90 degree, guys, 300. You can see that. That's good. You can try for any other values. What happens here? Let us take this time, we make this one 300, x is 300 and y is 0. Now you should know that the magnitude will be still 300 only because our vector is looking towards x, 300. Now our vector is like this. So x is 300, y is 0 over here, and the angle you can see it's a 0 degree. Let us run and check. If I save, come back and run the code, you can see that we have 0 degree and the magnitude is 300. This is how you write the code, guys. Now when the control comes here, it creates a position. It goes to the vector2d constructor and it returns back and it copies those values to position vector. And when you say position dot magnitude, it goes to the magnitude property. It calculates everything, return back to us the magnitude. You can see that one. If you want, you can put a breakpoint, attach a debugger, how it is working. You can see if you want. You know already how to put a breakpoint and work, right, guys? If I run the code, you can see now we are in the start method and it has a position vector 2D type and it has angle 0, magnitude 0 by default, x is 0, y is 0. That means at present your game object, you can say like it is present over here. X is 0, y is 0, angle is 0, magnitude is 0. Everything is 0 means your game object is over here. Now what you are doing means you are moving your game object in x 300, y 0. That is what it does, guys. Say step into. You can see that we came to vector 2D and you can see that vector 2D has x, y and this. And this is actually pointing to our current object which has x 0, y 0, magnitude everything 0. And you can see x is 300 that we have sent to the x member of the vector 2D and the y member will be having 0. Of course, this dot x equal to x, the next statement is going to do, and you can see that the current object's x is 300, and automatically you can see the magnitude also has calculated to 300. That is really good. And this dot y equal to y, we are going to set the y value. Now that is going to be 0, and this dot y is still 0, magnitude is 300. Still the angle has been not, angle is still 0, you can see. Angle is also calculating side by side. And it returns us a copy of that vector back to us, this vector, right, this new vector. That copy will be returned back to us, and you can see that our position vector is now having angle 0, magnitude 300, x 300, y is 0. Position dot magnitude, when you say, automatically it has calculated the magnitude for us, and it will display that 300 on the screen. Then it will display the angle. That is how it works, guys. I think you got the output. Similarly, you can try for other things. Let's take an example for 0 and 300 if you are trying for that one. And I change this one to 0 back again, so that I can able to explain you guys how it is working. It is always better to know how it is working. 300.0f. Let us save, again run the code so that we see from scratch. Let us run and check. We know that now we are in the start function. Position vector has the values 0, 0, 0, everything, and we call the constructor. We are here, and we have this variable is pointing to the newly created memory location. We know that, and it has all the values 0, 0, 0. Let us apply this dot x equal to x, and once it happens, this dot x is 0. Still magnitude is 0, angle is 0, y is 0. Let us y also be set, and you can see this dot y equal to y. We have set 300, and the magnitude is 300. Angle also calculated to 90, guys. So when you are creating the object, at that time only your properties also going to calculate. That you need to observe. Then it sends back us this data structure where this is pointing back to us, and by one the values will be copied back to our position vector, and the position vector is now having the angle 90, magnitude 300, x 0, and y 300. And when you run the code, you can see the magnitude will be 300 and angle is 90 degree. This is how it works. So you can understand yourself. You need to put just a breakpoint and understand how the code is working. I hope you guys have understood how do we create the properties, how actually the code is working behind the scene. I think for this tutorial, this much is enough, guys. Keep learning, keep coding. I hope you guys have understood new things. See you in the next tutorial.